Meet Daniel. He's been with the company for 12 years. He's quiet, reliable, always does the right thing, until the day he didn't. Nobody noticed the resignation letter that Daniel typed but never sent, and there's no end in sight to the long weekends and late nights that he has to work to keep the system up and running in production. All it took was one bad day, one script, one call to an API that was never meant to be public, and everything changed. Daniel didn't hack the system, he just used it the way that it was written, with too much trust baked in. You see, this isn't a talk about hackers in hoodies that are trying to get access to your internal secrets in your system. It's about something far more perverse and insidious: users. Because in a distributed system where applications and identities can span environments, clouds, continents, trust isn't a feature, it's a bug. My name is William, and let's talk about how to fix that. Before we get there, though, a quick disclaimer. You might think with a title like this that I'm a cat person. I'm not a cat person. For those of you that are dog people in the audience, don't get excited yet, because I'm not a dog person either. I'm any animal that is affectionate, wants cuddles, can play with me, gets scritches, and I can have a good time with. That's the kind of animal person that I am. So whether it's a cat, or a dog, or a chicken, or a goat, I'm that kind of person. In fact, when I was growing up, my grandparents had a farm. And on that farm, there was a cow, E-I-E-I-O. And I used to call this cow Bessie, probably because her name was Bessie. But she was a very cute cow, very sweet. And when the children used to get up in the mornings and go to the area where the livestock animals were kept, she would follow us around the whole day and nuzzle up against us and have fun. I used to play fetch with her, actually, true story. I would take a stick or a seed pod and I'd show it to her and wave it in front of her face, and then I would throw it. And I swear every word of this is true. I would throw it and she would ignore it. But when I went to go fetch the stick, she would follow along, rubbing up against me and having a good old time. She was my favorite cow. 10 out of 10 do recommend pet cows. Security is a big topic, and there's a lot of consultants that make a lot of money helping you improve the security of your system. My specific niche is helping you make the security of your message-based systems more secure. So what I'm going to do is I'm going to tell you exactly what I am going to cover in this talk and exactly what I'm not going to cover in this talk. So that if you think I should be covering something that I'm not, and there's a different talk that you would rather learn from, you're welcome to leave. The worst thing I want is for you to sit here for the entire hour and get annoyed that I haven't covered the topic that you think I should. The first thing I'm not going to cover is anything to do with authentication. I'm going to assume that you have some way of authenticating your users already. They come to your application, they present some credentials, some token, some cookie that proves that they are who they say they are. I'm also not going to cover anything to do with TLS encryption. I'm going to assume again that you've got TLS encryption across all of your services. That should be the bare minimum entry when you come into a security talk. I'm not going to cover anything to do with token exchanges. I'm not going to cover how to do token exchanges, because that's very dependent on the technology you're using to issue those tokens. What I will cover, though, is why you might want to do token exchanges and the reasons behind that. I'm also not going to cover how to secure your databases or your file servers or your web servers or anything like that. It's not an area that I find particularly interesting, so I'm not going to cover that. What I will be covering, though, I'm also not going to cover anything to do with front-end security. I'm a back-end guy. That's my zone. That's where I'm going to stay. What I will cover, though, is why and how to track identity within messaging-based systems. We'll cover a few techniques there. We'll also look at the basics of zero trust in messaging. At its heart, this is a talk about zero trust in messaging-based systems. So we're going to spend quite a bit of time talking about zero trust and what that means for system development. We'll also look at personalization of data from a security perspective. We'll see how we can personalize the data that we send in messages. And we'll look at token expiration and why it's important to plan for token expiration in distributed systems. We'll also cover how to version the security rules within your applications. And then, because I know at least one of you is in this room for it, there will be plenty of cat memes and pictures along the way. So don't worry, they're coming. I'd like to introduce you to the inspiration for this talk. This is my cat, Butterbean. Everybody calls him Butt. Not because it's short for Butterbean, but because he's an asshole. He doesn't like anybody except my daughter, so I'm comfortable in saying he doesn't like any of you because you're not her and she's not here. The reason he's the inspiration for this talk is because when you work in Zero Trust, you need to assume that everybody that's in your environment is trying to make your life miserable. That is this cat's entire function in his life. He makes my life miserable. Or he tries. He does it cutely. Let's do a quick recap of modular monoliths, so we're all on the same page with that. So a modular monolith exists on a spectrum of deployability within systems development, where on the one end of the spectrum, you might have something like a monolith, where it's a single application. You check out one code repository, you load it up on your IDE, and you can start developing. Maybe there's a database, maybe there's a second application server you can connect to. It's very simple stuff. This is nice from a development experience because there's only a few moving parts. However, as time goes on and you work on the system for longer and longer, there's a high likelihood that there's going to be coupling between all the components of the system. And when you get a high degree of coupling in a single code base, we eventually end up calling this a big ball of mud. Not so pleasant to work with at that stage. So that's a monolith, which is on one end of the spectrum. On the other end of the spectrum, you might have something like microservices, where every capability that your application exposes is deployed as its own separate process, own separate app domain. This attempts to address the concerns of coupling because all of these microservices will communicate via passing messages to each other. They won't call each other directly, which means that it's harder to have tight coupling between these components. However, the development experience is less than optimal because you might have 5, 10, 20, 50 different endpoints you have to spin up just to get your system running in your development environment. So the modular monolith is an approach at compromising between these two approaches and taking the best of both, where it says, we're going to develop our application as a monolith, as one single system. However, we're going to have some rules. The functionality or the capabilities that our application exposes will be segmented into modules, and these modules cannot communicate directly with other modules. They have to communicate via passing messages along an implementation of a mediator bus, some sort of implementation of that. What that means then is that it's harder to increase the coupling between these modules of your system because they have to communicate via message passing. This also gives us a few benefits. For instance, if we decide we need to take module C and we need to extract it out of our main application and deploy it somewhere separately, whether that's for scalability reasons or compliance reasons or reliability or availability reasons, we can take module C and deploy it somewhere else. It's now out of process of our main module. It needs a way to communicate with the other modules that remain behind, so we would typically use something like a message broker to do that. And module C would communicate with the message broker. The existing modules that remain behind, module A and B, they don't know that module C has moved. They still communicate directly with the implementation of the mediator pattern. The mediator pattern is the one that knows that module C has gone outside. So the mediator pattern communicates with the message broker. Module A publishes a message, it goes to the mediator bus says, oh, this message needs to go to module C. I'm going to serialize it, persist it onto the queue, and the queue makes sure that it gets to module C. None of the modules know that they're in separate applications or not. This is exactly the same as getting a kitten. When you get a kitten, you deploy them not into an app domain, but into a safe room in your house. You keep the kitten there for a week, 2 weeks, until they're comfortable. Depends on how loud your house is, what other smells there are. You want the cat to feel safe in this room that they're in, and you keep them there for a while. You don't interact with the cat via an API gateway. The cat has a name that you assign to it, and you start using to play with the cat. Instead of capabilities within the room, we've got various functionality that the room has, such as toys for the cat to play with, or food for the cat to eat, or a litter box for the cat to do the other half of eating with. And the cat doesn't interact with these capabilities via a mediator bus, it interacts with them via scritches and play and cuddles and just exploring and becoming a kitten. Eventually, we can take some of these capabilities and deploy them elsewhere in the house. So we can take the litter box, deploy it in the bathroom, for instance. And eventually the cat has the roam of the rest of the house that it can explore because now it's safe and it's comfortable. I think we can all agree I've proven that software development is like herding cats, and the project managers are right about us after all. So let's take a look at what happens when we let our monolith out from a security perspective. Now, when users interact with our monolith, they present their credentials. So they have some sort of token that says, I am William, this is the proof that I am William. That token gets provided to the application, and everything that the application does, all of the process and the modules do, know that William is the one that triggered that work. He triggered those operations. This is fine up until we take one of our modules and deploy them somewhere else. Because now, let's say module A creates a message and says, this message is charge customer's credit card 50 kroner. Great. That message goes via the mediator bus and the message broker to module C, where it's supposed to belong, where it's processed. However, module C doesn't know who triggered that message anymore. That context has been lost because we've lost the safety of a single app domain once we've scaled module C out. Which means we need a way of propagating the identity along with the message. So we need the identity of who triggered that message to flow along. And there's a few options that we can do. For now, what we're going to do is we're going to say that if our message looks like this, if it is charge credit card, we're just going to include the user ID as part of the message and send that along. Later on in the talk, we'll kind of circle back to this and see why this may or may not be sufficient, depending on your environments, and we'll look at a few other options. But for now, including the user, the identity as part of the operation is sufficient. And if you do this while your application is still a monolith, it means that when you migrate parts of your modules and expand them out, you don't have to do a bunch of refactoring later on. And including the user ID as part of the operations, whether it's a property on the message directly or as a header on the message or some other metadata, makes the intent behind the message clearer as well. For Butterbean, sleeping is an activity that always involves a person. He loves to sleep on people's chests. And by people, I mean my daughter. If she's not available, he'll settle for somebody else. But for him, sleeping as an activity always involves an identity. So if we take the same approach and we say every message that we send, before we send the message, we include the identity in the envelope of the message, then we'll be able to make sure that we can track who triggered what operation in our system. And this is probably one of the only ones that I'll recommend we do even while your application is still a monolith, because it's such low cost and high benefit to do. Let's have a look at authorization. This is a picture of Butterbean on my driveway with my daughter. He loves the driveway because the dogs aren't there. There's also a tree that he can scratch and sharpen his claws on, and there's lizards he can hunt if he wants. It's one of his favorite places to be. If I have to go up the driveway, which it's about 50 meters or so, if I go up the driveway to maybe take the dustbins out for collection day, or if I go collect the post, he follows along and he rubs up against my legs and he's very affectionate while I do this, until I get to the top. As soon as I leave the dustbins there or I collect the post and I turn around, he locks eyes with me. And then we've got a bit of a stare-off going on, because now, in his mind, he's not authorizing me to come back down the driveway. So I need to plan the route that I'm going to take. I have to run over him or jump past him or double fake him so I can get past into the house. And in messaging-based systems, we've got a similar thing we have to take care of. We've got two aspects we need to look at. First of all, sending commands. In messaging systems, commands should go to a logical place. The charge credit card message should always go to the credit card service. It's the only one that should be authorized to charge credit cards. However, the request, the message that gets sent, can come from many different locations. We need to make sure that the people that send those messages to charge the customer's credit card are allowed to send those messages. The flip side of this in messaging systems is events. An event comes from a single location. The customer's credit card has successfully been charged is an event that will get published. It can get published and it will go to many different locations. We need to make sure that the locations that it goes to are authorized to receive a copy of that message. So let's have a look at that. I'm going to quickly simplify this diagram a bit because there's a lot of noise that we don't need. I'm going to take the API gateway away. We don't really need that for this. I'm also going to take the module B, D, E away. They're still there, but we just don't need them for the purposes of this discussion, which means we've now got a slightly smaller diagram we can use. So now let's take a look at authorizing the sending of commands. In the happy path, the way that it works is module A says, hey, we need to charge the customer's credit card 50 kroner. Module A sends the message to the mediator bus. The mediator bus says, oh, okay, this message needs to go to module C. Module C is out of process, so I'm going to serialize this message, put it on the message broker, and the message broker will make sure that it gets to module C. Module C takes that message and then charges my credit card 50 kroner. Great. That's exactly how it's supposed to work. But let's assume we've got somebody there who's trying to ruin our day, and they've got access to our connection string to connect to our broker somehow. We don't know how they got it. Maybe we checked the connection string into our repository or something. We didn't see it during the code review because it was removed on the next commit, but it's still there in the history. Or maybe it's a disgruntled employee. Or maybe it is actually just these amazing hackers who are able to get access to our infrastructure. It doesn't matter how they got access, you assume they have access. This is the first tenet of zero trust security. You assume that somebody has got access to your infrastructure. What do you do in this case? If they've got access to your infrastructure, what this means is that they can go and create a message and say, hey, this message is charge William's credit card 50,000 kroner. Put that message on the queue. It goes to module C. Module C says, oh, okay, I'm going to charge William's credit card 50,000 kroner. That's not ideal for me. I like having the ability to have money one day in the future. How do we prevent this from happening? Thankfully, this is an easy one of the few easy ones we've got today. You can solve this using asymmetric key cryptography. So the way this works is module A, when it generates a message, it signs the message using its private key. Nobody else has got access to module A's private key, so it takes the message, signs it, and includes the signature as part of the message. The message goes through the mediator bus, through the broker, it ends up at module C. Module C can then take a look at that message and the signature and validate that it was actually signed by module A. It means that any malicious actors that have got access to our infrastructure, they don't have access to the private keys to sign the messages, so they can't send messages that we have to honor. And if we get a message that doesn't have a valid signature, we can discard that, and we don't have to honor that message. Now, you don't want to do this in the modules because I don't know how many modules you have in your system. You don't know how many modules you're going to have in your system after 5 years worth of maintaining it. So ideally what you want is you want this signature management and verification to happen in your implementation of the mediator bus. So when module A sends a message, it goes to the mediator bus, and the mediator bus says, oh, this message needs to go out of process. So I'm going to now sign the message. If the message doesn't have to go out of process, there's no need to sign it because it's a lot harder to inject a message on an in-memory bus than it is on a message queue sitting externally. But if it does have to go externally, the mediator pattern will sign it. Conversely, when a message comes off of the bus, we want that signature verification to happen in the mediator bus as well. We want to look at the signature, determine whether or not we should honor this message before we pass it on to the module that is going to process that message. If you're using Jimmy Bogart's mediator package, something like this would work. The code isn't important. What we need, though, is we need whatever implementation we have of the mediator pattern, it has to be able to take the existing message, modify it, and add additional information before passing that message on to the next step in the process. We need a pipeline behavior so that we can adapt the message as we send it. And conversely, when we receive the message. If we do that, we'll be able to say no if we receive a message that isn't signed. And cats are just really good at saying no to things. They seem to be genetically enhanced to say no to things that go on around them. Being able to sign the messages using private keys as they leave your process allows you to then, when you receive those messages, decide whether or not you need to process that message or discard it. That was the one side of the coin, being able to tell who's sending the message and make sure they're allowed to send the message. The flip side of that is stopping them from reading messages that they get. This is Butter being in my daughter's bedroom. She likes to say that he's reading her books while she's at school. Obviously, he's not doing that, and not just because he's an illiterate idiot, but also because he's the laziest shit you'll ever meet in your life. How do we stop people from reading our messages, and why do we need to stop them? Well, module A sends a message. Customer's address has been updated. Module C needs this information because if we're charging the customer's credit card, we need to know the address to put on the invoice. So we send the message and it goes to Module C, and Module C updates that customer's address. Except that's pretty sensitive information, right? That's clearly GDPR related. We need to make sure that that sensitive information doesn't go outside. Which means if we have a malicious actor who's got access to our message broker, they can very easily set up a subscription on a topic to receive a copy of that same message. Which means when Module A sends a message, a copy of it will end up in our malicious actor's inbox, and they can collect that information and sell it off to telemarketers. This, at least, is also easily solvable. We use asymmetric key cryptography again, just in reverse. So now, when Module A sends a message, it goes to the mediator bus, and the mediator bus says, okay, this copy needs to go to Module C. So I'm going to use Module C's public key to encrypt the message. Once it's encrypted, I put that encrypted message on the message broker, and it goes to Module C. Module C takes the message off, and it can use its private key to decrypt the contents of the message. If that message ends up in our malicious actor's inbox, they don't have access to Module C's private key, so they can't decrypt the message. So thereby, we stop them from being able to read the message if they're not supposed to have access to it. Again, if you're using Jimmy Bogart's mediator package, something like this would work. Again, the code doesn't actually matter. The tool that you're using doesn't matter. What you need is the ability to replace the body of your message with an encrypted version of that message as well. If you do that, if you're able to do that, then you can prevent people from reading messages that they're not supposed to have any access to be able to read. The key part here is that we need to assume that somebody has got access to our infrastructure. If they have access to our infrastructure, how do we still prevent them from doing things that they're not supposed to be able to do? I said there were two parts. There was sending commands and reading events. I lied. I'm sure we know cats are really good at just knocking things off. They're pretty good at it. I don't know why. They seem to have a special joy out of it. This one is particularly great because I love the fact that the guitar adds insult to injury right at the end there on his head as well. The cats are these destructive little furballs, and they take joy in just being absolutely malicious. And we've got the same problem with our systems. People can discard messages. Again, the happy path, Module A creates a message, puts it on the bus, it goes to the broker sends it to Module C. That's the way it's supposed to work. But if somebody's got access to our message broker, they don't have to set up a subscription on a topic. They can consume messages directly from Module C's queue. This is a very useful pattern in distributed computing. We call this competing consumers. Very powerful technique, very useful. But in this case, it means that a message will go from Module A on the broker, and it could end up in our malicious actor's inbox. If we have encrypted the message and signed it, maybe they can't do anything with it, but they can discard it. And if that operation, if that message was a transactional message, something with monetary value, that means we've lost that. I'd like to say that this is an easy fix, but unfortunately this one isn't. Because if you've got access to if someone's got access to your infrastructure, they can consume messages, and there's nothing you can do about that. What we can do, though, is be a little bit creative. We can reduce the impact of that. So this is a picture of documentation coming from HashiCorp Vault's key management system, and they've got this concept of dynamic security credentials, where instead of asking the key management service to give you the username and password that all things use, you ask for a username and password, but in the background, it goes and provisions a new user account for you. That user account is only valid for a certain period of time, which means if that account is leaked, the only malicious information or the only malicious activity that the people that have that leaked account can do is for that duration. Now, with the HashiCorp Vault's documentation, they show an example of 7 days. But there's nothing in there that says you can't go from 7 days down to a few days, down to a day. You can shorten it from a day to a few hours, from a few hours to an hour. I believe the lowest you can go with HashiCorp Vault is a few minutes. I'm not here to tell you to go and use HashiCorp Vault, far from it, but the idea is interesting. So maybe we can do dynamic credentials, or we can take something from this and apply it in different places. So if you're using RabbitMQ, you can go and do dynamic credentials. It's very quick to go and provision a user. It's still 2 remote calls, so it still takes a bit of time to do this. We can get creative, though, so instead of having a new user created every time. Maybe we have a pool of users, and all we do is we change the password of the user when somebody requests it. That reduces it down to one request. Or we could have a rotating pool of users that are valid for a certain period of time with known credentials, so we don't have to make any network calls. And we can have these rotating credentials that are only valid for a certain period of time, in RabbitMQ at least. You might think maybe we can do the same if you're using Azure Service Bus. No, because provisioning a user in Azure takes anywhere from a couple seconds up to a few hours. You've got no guarantee for how long that is going to take. What you can do, though, is you can use rotating tokens. You can rotate tokens very, very quickly so that the access token is only valid for a few seconds. And that creation of that access token is super fast. And you can do similar things in SQS. The technique here is using dynamic credentials to be able to access resources and having those credentials be as short-lived as possible so that if they are leaked, the only amount of time that somebody can do something malicious to your system is while those credentials are still valid. Let's look at personalization. So personalization is the third aspect of security. If you've got authentication, this is who I am William. Authorization, William is allowed to access this screen that shows all of the transactional information for the day. And personalization, yes, William's allowed to see the screen, but he can't see the dollar amount of all the transactions for the day. The information I see is slightly different to what other people see, and that's based on security. And this is particularly important when it comes to messaging-based systems because we publish events fairly often. And if we publish events, we don't necessarily know where they're going to go all the time, because if you publish an event now, in 3 years' time, you don't know how many other systems have subscribed to that event. Are they allowed to get all that information? For instance, in an order shipped event, the recipient name, address, contact number, and email address is personally identifiable information. That's not okay to just share. But the act that an order has been shipped might be useful for people that don't necessarily need access to that information. If you need access to that information, sure, that's legitimate interest. But if you don't and you get this information, that's a violation of GDPR. How do we prevent this? How do we make this more secure so that we can publish the event and still know that only people that have got access to that information will be able to read it? We can use partial message encryption. So when we send a message, before we send the message, we decorate some of these properties, and we say these properties are sensitive, which means as we send the message, it ends up on our mediator bus, and the mediator bus can go through all of these sensitive properties, take the ones that are sensitive, and encrypt them, replace their value with an encrypted value, which means the event, the message as a whole, the order shipped event, still goes to whoever wants to subscribe to that information, whoever wants to know that the order has been shipped, but the sensitive information is only readable by the people that have got access to the keys to decrypt that information. If we are using attributes, we can do some cool things like parameters in there. So we can say that the address, the contact number, and the email address are only readable by people that are in the dispatch role. So we can use a specific key for the people in the dispatch role to encrypt those properties. Or if they're in the customer services role, we use a different key. So we can get quite clever around the types of keys that we use to encrypt these messages before we send them along. What we're doing here is we're taking the sensitive information that is on all of our messages, and we're only encrypting the parts of it that are sensitive. Partial message encryption is very powerful here because it means that everybody that needs water can get the water, but only the people that know how to use a tap will be able to consume the water from the tap. Let's look at token expiration. So Butterbean likes having his belly rubbed, but the offer to rub his belly is only valid for a certain period of time. And you don't know how long that offer is valid for. He presents his belly, you've got a certain amount of time to get in there, give him scritches, and get out. If you get that time wrong, he latches on with his front paws and holds onto your arm and uses his back paws to try and get the insides of your body to be on the outsides of your body, which is problematic because the inside of our body is where I keep all my blood and stuff. The same thing happens with token expiration. So the way it normally works is you send a message, the message goes on the broker and it gets processed by module C, and this should take a short amount of time. However, it doesn't always. Whenever you're doing messaging-based systems, things can go wrong. Maybe there's a message in the queue already before you send your message. Maybe there's lots of messages in the queue before you send your message. You send your message, it goes to the back of the queue. There's no guarantee that your message will get processed now, even today, even this week. If it ends up in a dead letter queue somewhere, it could be months before that message eventually gets to the front of the queue. And when it does get to the front of the queue, if we're using the token of the user that sent that message, it's a high likelihood that that token will have expired by the time it gets to the front of the queue. So what do? Does Module C honor the message if the token is expired, or does it discard the message? We're going to look at 3 approaches here. We're going to take a look at forwarding identity along with the message. We're going to look at using a custom data structure, and then we'll look at token exchanges and why that might be a valuable approach. Forwarding identity is where the user presents their token to the application that they're working in. As your module creates the message and it says, this message is now created by William, instead of sending the token along with the message, we take the user identity. We take, William created this. This is the exact same example we had at the start of the talk. We're just sending the user ID along with the message. This is low effort, but it's not very secure, because a malicious actor can go and put a message on the queue and say that it was sent by John, even if it was sent by Daniel. Let's take a look at another approach. What about a custom data structure? So in this case, as we generate the message, we take some other information about who triggered that message, and we create a custom data structure around it, and we append that to the message. This custom data structure will include things like the username, first of all, as well as whatever claims the user had at that point in time when this message was generated. Then we include a hash of the message, or of this data structure, not the message, sorry. We include a hash of this data structure so that we know that it hasn't been tampered with when we receive the message. We can then say, well, at this point in time, these were the claims that the user had, and whether or not we need to honor the message when we process it. This is slightly better than just sending the user ID, because we can make sure that people haven't tampered with this. However, a malicious actor can still mess about with us. They can take a message that's on a queue somewhere, take the existing user identity, make a copy of that, and stick that on another message. So it's a slight improvement over the user identity, but it's still not foolproof. It depends on how secure you need your environment to be. What about token exchanges? So a token exchange says, well, I'm going to generate the message, and instead of appending William's token to the message, I, as module A, will put my module A token on the message. So I exchange William's token for my token, and I put my token on the message, and that flows along with the message. This has a few requirements, though. The first is that you're making the assumption that module A's token has got a longer expiry, is valid for a much longer period than William's token. And that long expiry, you need to make sure it's long enough that no matter how long it takes for that message to get processed, that token will still be valid at the end. We also need to include a hash of the message, the entire message, including the message ID and all of the metadata around when that message was enqueued. Because if we don't include that, somebody can simply copy messages exactly as they are and place them on the queue again. As soon as you copy a message and place it on the queue, things like the enqueued time changes, the enqueued sequence changes, so the hash will change. If the hash includes all of that metadata, it means we can make sure that we know that the message has been tampered with and we can discard it. This can also be a refresh token, which is essentially a URL where you're outsourcing the decision of whether or not the token should be refreshed. So the refresh token says, well, I've got the message now, the original token has expired, I'm going to ask my token server if I can refresh this token. The token server will then go and make the decision, yes or no, this can be refreshed. If they say yes, the token server will issue you a new token, and you exchange the current token with that new one. What we need to be aware of, though, is that if you're in a messaging-based system, tokens will expire at some point. You need to know how you're going to recover from that. And there's techniques that you can do. Once a token has expired, we need to know that, okay, well, my system is now back up and running and it's able to process things again. What do I do with the expired tokens? Have a plan up front for what technique you're going to use so that when your system does start responding again, you know how to process them. Let's talk about version and security requirements. So Butterbean's life has gone through a lot of changes since we got him. When I got him, it was my wife and I and him. I could still grow hair, thick, luscious, curly hair. Life has been cruel. Not as cruel as to me as it has for him, because he's now got 2 dogs around, he's got kids. The only one of these changes he liked was one of my daughters. The rest of it has made him even more grumpy than usual. But life has changed. When things change in our security or in our applications, we need to be able to version these things correctly as well. So if we make security changes, we need to version these requirements correctly. For instance, if we send a message from module A, it goes to module C, everything's fine, happy. However, maybe we decide that we want to deploy a new version of module A that treats the charge credit card message differently. We want to encrypt the credit card number so that only the billing role has got access to read this number. Well, that's fine, except if we send this message, module C doesn't know how to read this message, right? Because it's expecting a billing number in plain text. Well, William, don't be silly. You've only got 2 applications. Just deploy them at the same time and everything's fine. Sure, except what if you've already got a message sitting in the queue using the old format, and you've now deployed module C that expects a new format? Module A is going to send the new format down, but module C has to read messages using the old format as well as the new format, because you've got messages that are already in flight in the queue. If it's not able to do both of these, you could get a crash, or you could lose information. So being able to have multiple keys, multiple formats, that when you send a message, you can receive the message in multiple ways and be able to decrypt that in multiple ways is very beneficial. More so than this, if you change the keys, you need the destination to be able to use different keys to be able to decrypt that information. What you want is you want your mediator pattern to be able to send a message using a range of keys, not a specific key. You also want, on the recipient side, when you take a message off of a message broker, you want to be able to validate any number of keys that the message contains. Which means what we need is a key management service. We need the ability to have multiple keys that are involved in this. So when we send a message, we might include something like the key ID that was associated with this message. Not in the body of the message like this, but probably some metadata that goes along with the message as well. When we receive the message, we can ask our key management service, hey, can you give me this key? The key management service at this stage can decide whether or not you should have access to that key. If you do have access, it will return it. If you don't, it won't. In fact, you could have many different keys in your system. If you really wanted to, you could probably have a unique key per message that you send. Wow, I don't want to see your key management service bill at the end of that. But you could, if you really wanted to. Having a key management service allows you to rotate your keys frequently. And if you rotate your keys very, very frequently, it means that it's unlikely that somebody will be able to get access to that key to do something with it. Being able to rotate your keys means that you can reduce the chance of somebody being able to use a key to do something malicious within your system. We've taken a look at 6 different things here, including identity in your messages. This is probably the only one that I suggest we do, even while the application is still a modular monolith, because the cost of this is so low. The rest of them all depend heavily on your requirements, because they all have a cost associated with them. Some of them have a direct monetary cost. Some of them have a complexity cost. Some of them have an implementation and a support cost. You need to decide which of these techniques is appropriate for your environment, for your requirements, and decide whether or not it's important for you to implement. If you do decide some of these are important to implement, maybe then you can be able to keep your little toy as safe as Butterbean keeps his. Now, originally, when I was coming up with this talk, it was going to be all cat memes all the way through, because they're objectively the best humor in the entire world. Unfortunately, though, as I was preparing this, Butterbean passed away. So I thought, what better way to honor his memory than to get up in front of a room full of people that didn't know him and spend an hour telling them what an asshole he was. An asshole that I miss. I've got quite a bit of time for questions. I hope you had fun. But I would prefer if we answer the questions outside or at the party or in the venue later on. Thank you very much. I hope you learned something.